All right, so chapter 7 has this making reasonable inferences based on proportion statistics that we also covered on homework day 8 as part of chapter 3. But if you didn't get it done in chapter 3, it's going to show up as in chapter 7. So just to refresh your memory, these are the exact same ones we did on homework day 8. But it says here, in a study of pain relievers, 20 people were given product A, all but 7 experienced relief. In the same study, 100 people were given product B and all but 21 experienced relief. Fill in the blanks for the statement that makes the most reasonable possible. Product blank performed better in the study because what percent got relief? So I'm looking for the percent of each of them that got relief. So on product A, we had 20 people, all but 7 experienced relief. So we would know 13 out of 20 got relief, right? If you do 13 divided by 20, what percent is that? 65%. If I do product B, for product B, all but 21 experienced relief. If we had 100 people, 100 minus 21 would be 79, right? And 79 divided by 100 we know is 79%. So, which one performed better? Product B did, because 79 got relief, whereas only 65% of product A got relief, right? If you did these when we did homework day 8, they won't be on your pie chart. But just in case, I figured I'd review them. Number 2, the record of a computer retail store shows that out of 100 customers who purchased a desktop computer last month, 69% also purchased the service plan that extends the warranty for an extra year. Out of the 50 customers who purchased a notebook computer last month, 40 purchased the same service plan. So fill in the blanks. Last month the customers of the store who purchased what kind of computers were more likely to purchase the service plan? So on the first part, we had 100 customers, 69 of them, 69 out of 100. That was for the desktop. So we know that's 69% of the desktop. For my notebook computer, 40 out of the 50 purchased the plan. So 40 out of 50 is what percent? 80. So, who was more likely to purchase the plan? The ones who bought the notebook computers. So we would have notebook in here. They were more likely because 80% of them purchased the service plan, whereas only 69% of the people who got the desktop computers purchased the service plan. The third one, that was the one where it was a little weirder worded, said in a recent study, 100 males used the new weight loss supplement. All but 28 of them experienced weight loss after 2 weeks. In the same study, 25 females used the same supplement, and all but 3 of them experienced weight loss after 2 weeks. The new weight loss supplement was less effective in the study because what percent of them failed to lose weight? So if I'm looking at how many failed to lose weight, on the first for the males, all but 28 of them, so 28 out of 100 failed to lose weight, 28%, right? On the females, all but 3. 3 out of 25 is what percent? %. Failed to lose weight. So This one was worded weird because it says which one is less effective. And normally you'd probably think of, oh, the percent that's lower is less effective, but that's really the ones that failed to lose weight. So 28% was less effective than the 12%, right? So in other words, the males did worse in the study because 28% of them failed to lose weight, whereas only 12% of the females failed to lose weight. All right, so those ones we did before. For the next ones, if you're not logged into ALEKS, you need to log into ALEKS because you need to use the ALEKS calculator. Last time, way a long time ago, like the 27th of February, we did the Z-score distributions. Today we're doing the T distributions. You use the Z-score when you know the standard deviation. You use the T distribution if you don't know the standard deviation. And so it's going to sort of work the same way as what we did last time, but just a different table that you could use, or in this case, the ALEKS calculator. So let me know when you get to the ALEKS calculator. It doesn't matter what problem you're on, just go to whatever problem's there on your pie chart, and then hopefully the calculator is active. Are we ready?
Yep, come in.
All right, so last time we talked about having that normal curve and that we have a critical value of where it falls. And so on the ALEKS calculator, the T, if you look for the T, you're going to have something that looks like this. P of T is greater than, right? So when they're calculating the critical value, they're calculating the values to the right of that line. If you're going to do a less than, like we are on this first one, we have to do 1 minus that value. P of T is less than, or is, I flip my sign around, greater than 1.87 in this case. The whole curve would be 100%, that would be 1. We would subtract off this part to the right if we want to know the part to the left. So on the ALEKS calculator, you're going to type in 1 minus, and then you're going to do the P of T is greater than your 1.87, since that's what we're computing. And it says the degree of freedom is going to be 8, so you'll see a little DF and you're going to put an 8 in there. And you're going to just punch that into the calculator, hit equals, and round your answer to 3 decimal places.
049.
That doesn't sound right. Well, clear that out for me. So 1 minus, and the P of T, yep, that's the one, of 1.87. And the degree of freedom is supposed to be 8. That looks better. I don't know what happened before.
Yeah. 951.
So 0.951. Anton, are you getting that answer too? Got that figured out on how to punch that in? Not logged in yet, thinking of something else? Oh, still looking at what you need to hand in yet. All right. The next one, we are going to find the value in the middle of 2 numbers. So we have our curve, and we have 2 values here and here. We know that the part in the middle is 0.99, and we need to find out what these values here and here are. So first thing we're going to do, because we know the whole curve is 1, is we're going to do 1 minus 0.99. If you do 1 minus 0.99, it's going to leave us the area on the 2 outside spaces. If you do 1 minus 0.99, you're going to get 0.01. Now, because that is both of these two spaces, and these two spaces should be the same size, but I can't draw, I'm going to divide this by 2. So if you take your 0.01 and you divide it by 2, you get
0.005.
Okay, so the area in this section is 0.005. The area in this section is also 0.005. Since I'm finding the area, now I'm going to use the T sub, the one with the little box. See that one on the Alex calculator?
Yep.
So I'm going to put T sub 0.005. Again, it's going to ask for the degree of freedom, and on this one it says 22 is what we want to use for our degree of freedom. .819, 3 decimal places again it says. 2.819. Okay, so 2 ways. One where you're finding the area under the curve, that's what the P of whatever, you're finding the area in that spot is 0.951. Or they give you the area and then you have to find out what the critical values are. That's why they use a C for critical value, 2.891. So if we look at the next one, number 5, this one we're between the two things again. So I've got my curve. We've got our two critical values, negative 1.29 and positive 1.29. And we want to compute that. So if we're going to compute that, first thing we're going to do is, and they're doing the less than, but we're going to find the area just in this little section right here. So we're going to do P of T is greater than the 1.29. And I suppose I didn't put my degrees of freedom. 18. I better put that. There, we'll add that on there. Degrees of freedom should be 18, it says up there.
107.
So, this I'm going to carry a little farther because at the end we want to round it off to. So I used 0.106689 and figured that was good enough. So the area in this section is 0.106689. The area in this section is also 0.106689. We want to find the area in the middle. So we're going to take 1 minus 2 times that value because we have that on both ends, right? To find the area in the middle. And then this one we can round off to 3 decimal places since we're at the end.
787.
Yep, 0.787. And they do give you a little wiggle room on the rounding because sometimes it will tell you in the problem of how far to carry out your rounding, and this one it doesn't. And so sometimes they give you a little wiggle room when you do your answer. So the next one is one where they give us the area, and this happens to be a less than. So I have my curve, I know my area less than this is 0.05, and I want to find out what that critical value is. So I'm going to find this part right here. If this area is 0.05, then this area would be 1 minus 0.05. Or 0.95, right? We now want to find the critical value, so we're going to do the T sub, And then we're going to put that 0.95 in there. Degree of freedom is going to be 12. When you do the area, it's always to the right. So if they give you the area to the left, you got to find the area to the right by 1 minusing that number, and then that's what's going to go in the box. So if you do T sub 0.95 with degrees of freedom being 12.
Is it a negative?
Yep.
Negative 1.782.
Exactly. So this critical value here would be negative 1.782. All right. So number 6 looks sort of like number 4, at least to begin with. Again, they give you a less than because they want you to get used to the calculator doing greater than. If it's a less than, we're going to do 1 minus that, right? So I'm going to do 1 minus P of T is greater than 1.34 with my degrees of freedom being 20. Zero point, did you say?
Yeah.
9. No?
Or, no, 0.098. No, 7.
Let's see what you got typed in there, because that's not what I got. All right, so clear that off. Yep. So 1 minus. Oh, we can do the 1 minus. Okay. Since it's a less and we want a greater. 1 minus, and then 1.34 with the degree of freedom of 20. Whoops, and you hit there. Hit undo. Oops, undo's right next to the clear. Now hit equals. There we go, that looks better.
Where we at?
We are on homework 14, chapter 7. Using the Alex calculator again. So, yep, there's chapter 7. We're just homework 14. Now we gotta get to the Alex stuff. Keep going. That's from the book. There's homework 14. All right. And again, this is just like on number 4 where we're doing the 2 critical values that are going to be the same number. We know the area in the middle is 0.9. So we're going to find the area on each of the 2 ends. So again, first we started with 1 minus 0.9, which gave us 0.1. Since there are 2 sections, we're going to divide that by 2. 0.1 divided by 2 gives me 0.05. That means that 0.05 is the area of each of those 2 sections on the end. We then want to find our critical value. So we're going T sub 0.05, which actually gives us the right here. And my degree of freedom, this time it says we're using 2. So T sub 0.05 with a degree of freedom of 2. And these you punch into the Alex calculator, so you might want to log on there.
Oh, okay.
2.92, and they're actually going to put 2.920 just to throw the 3rd decimal place in there. But if you put 2.92, you're probably still okay. All right. So last time when we had the X or the Z scores, they had those same kind of things, only now we're doing T's instead of Z's. All right. The next ones is a different kind of measurement. It's called chi-squared. It looks like an x squared to me, but it's chi-squared. But it's going to be the same kind of thing. I'm going to use the Alex calculator to find the values. And so again, if you notice on your Alex calculator for chi-squared, it's using the greater than symbol. So if I have a less than, I'm going to do 1 minus, just like I did with my t distribution. So I'm going to do 1 minus p of chi-squared is greater than 16 with a degree of freedom of 27, it says on this one. Yep, 0.047 would be 3 decimal places. And it does say at least 3, so if you carried it farther than 3, it will still be okay. Now in this one, when we do chi-squared, notice this is a greater than, so they were nicer on this one and didn't do all less thans like they did on the previous one. So since this is a greater than, we're just going to do this area. This is the area, so we're going to have the chi-squared sub box 0.025 with a degree of freedom of 27. So if it's a greater than, we're going to use that value. If it's a less than, we have to do 1 minus the value and then use that number.
I got 1.
You got what?
1.
I don't think so. Oops, we're not doing the p though, we're just doing the chi-squared.
Oh, okay.
Since we know the area,
just
so
this.
it's that one,
Okay.
yep. Notice we got the end answer, not the beginning answer.
I need a password
You need a password for,
for knowledge checker.
let's see. Hit these 3 little lines. And let me see if it lets you, it doesn't let you go into anything, does it? Let me log on to Alex quick here and just get rid of that. Alrighty. I wonder which knowledge check that is trying to make you do, unless you just clicked on it and it wasn't due yet.
It just says in the left, continue with the knowledge check.
Oh, you never finished your midterm.
Yeah.
That's our problem. Then it's not going to let you audit there unless you have to retake it. How far were you on your midterm?
Over half.
Over half? Then you probably don't want me to stop it in the middle. Just so you can work on the Alex calculator, log out of this. Yeah, just log out of Alex altogether. And then we're going to go back into Alex, but I'm going to have you log in with work study and work study 1, I think it is. We're gonna find out. Perfect. Type in work study. And then work study 1. Work study with the number 1. All right, go up here on the drop down, go into statistics, and go here, and go to student fields, and enter. My class. All right, it's gonna make us pretend we haven't done anything yet. Shoot. It's not going to work very well because it's going to take us further. Maybe if we get to the calculator. Next and next. Can you go up here to the main menu? Will it let you into the calculator? Nope, doesn't look like it.
We're just gonna go through.
Skip the tutorial. Skip again. Continue. All right. Now, click down here in this section. Now we have access to the calculator. There we go.
Oh, good. Yeah.
All right.
I'm in class.
Now, back to where we were at.
Oh, no.
So, did we write the answer down for that one? I don't think we did. On the second part of that, we were doing chi-squared 0.025 with a degree of freedom of 27. And so on the calculator, you're using that one right there. Yep. So again, on the calculator with all the area ones, it's always the area to the right. So if it's a greater than, you're going to use the number that's there. If it's a less than, you do 1 minus that number and use that for your value. If you type this in, what did we come up with for our answer? This one says to 2 decimal places. They changed it on us.
43.19.
43.19, exactly. 43.19. All right. On the next one, it says find the median of the chi-square distribution. If I'm doing the median, what is my percent? The median would be at what percent? 50, exactly. So when they ask you for the median, they're asking you for 50%. So basically, we're going to do the same thing we did up here. We're doing the area to the right. We could do to the left, but it should give us the same answer. So we're going to do chi-squared 50%. Yep, 0.5 or 0.50. And my degree of freedom, 27 again. We're going to punch that into the calculator to 2 decimal places again.
26.34.
Yep. 26.34.
Which one was it? The second one? This one?
It is this one without the P in front. Yep, it's that one. And so then we're going to use 0.5 or 0.50 for 50%. And then degree of freedom, it said we're doing 27 degrees of freedom. And then just hit equals. And so we get 27 or 26.34, right?
Okay, yeah.
All right. All right, so number 8, same kind of thing here. This time we are going to find the area between 2 numbers on our distribution. So we have a 15 and we have a 30. And so all we're really going to do is just subtract the two different areas. So I'm going to find the P of chi squared is greater than 15, which would be over here. And then I'm going to subtract the P of chi squared is greater than 30. Whoops, I should put my degrees of freedom in there. Because what I'm doing is I'm going to find this area here, but then I'm going to subtract the end part off. And of course I have to have my degree of freedom, which I always forget to write down, of 24. It tells me right there. So when I'm trying to find the area between those two things, I'm going to find the area that's greater than 15, and then I'm going to subtract the area that's greater than 30, and that will give us the area that's in the middle. So if you punch that into the Alex calculator,
Oh, we're using it for.
this is the one with the P in front. Yep. So 15, degree of freedom 24. Then on the other side of the parenthesis, type your minus. And then we're going to do the same thing again, the P of chi squared it's called. Yep, that. And we are going to put in 30 with a degree of freedom of 24. And hit equals. And so we end up with 2 3 decimal places, this one says.
0.737.
I got 36.
Oh, we don't round.
Oh, because it's a 0 behind there. Right?
Okay.
360. So the first part is finding your area all the way to the end. The second part is finding the area at the end. If you subtract those, you end up with the area in the middle. So what that's really saying is that you have 73%, 73.6% of the areas between those two numbers, is what that's saying. Those numbers are percentages. All right, the next one. Okay, is that the same as we did on the other one, except for they changed the degree of freedom? We are given the area to the right because it's a greater than, so we're just going to do the chi squared sub 0.025 with the degree of freedom of 24. If it's a greater than, you just use the number that's there. Punch that in again.
Okay, I use this one, okay.
Yep, you use that one. 0.025, degree of freedom 24, equals 39.36. That's what I got. Did you get 39.36?
Yep.
All right, 39.36. And the third part, again, is doing the median. If we're doing the median, what is the area?
50?
50%, right? The median cuts it in half, so 50% of it would be to the right. So we're going to do our chi squared, 50% with a degree of freedom of 24. Yep, 23.34. All right. Number 9, going to be the same kind of thing. Notice this one has a less than. When it has a less than, what do we have to do? 1 minus. So 1 minus P of chi squared is greater than 42 with the degree of freedom, this time being 29. The Alex calculator does the greater than, so if we have a less than, we have to do 1 minus that answer. 1 is 100%. Whoops. Let me think what's got hunched in there. Okay, clear that out. So 1 minus, oh, you didn't do the 1 minus, okay. Do 1 minus first. The number 1. 100% minus the P, there we go. And then the 42 with a degree of freedom of 29. There we go. And we got 0.944 when we rounded that off to 3 decimal places. That means that this area here to the left is 94.4% of my curve. This one's to the right, so if it's to the right, because it's a greater than, we're just going to use our number. This time they gave us the area, we're finding that critical value cutoff point. So we are going to have chi squared sub 0.1 with a degree of freedom of 29, it says. So if I get a greater than, I just get to use the number that's there. $39.09. So they're telling you that critical value here is 39.09 and that 10% of the area is to the right of that. And then again, we're going to do the median. And if we're going to do the median, what percent are we going to use? 0.5, 50%, right? Whoops, chi squared. 0.5 in my degree of freedom, 29. 28.34, exactly. Okay. So basically these first ones here, just getting you used to using that Alex calculator. 10, 11, and 12. Now they want you to get used to picking out which one of those tables do I use when I'm doing a word problem. Last time, way back 2 weeks ago or whatever it was, the 27th, we did the Z, which was our standard distribution. If you know the standard deviation in a word problem, then you use the Z table. The T1, we started off with the T1 today. If you're going to use the T1, the standard deviation is unknown and it has a small sample size. You can use either the Z or the T1 if your sample size is large and it's not normally distributed. Yes, I can talk. It doesn't have that normal bell curve like we're used to doing. So if it's not normally distributed, then I can use either the Z or the T. And then the last one where it says it's unclear, it's going to be unclear if it tells you that you know very little about the distribution. And the sample size probably is relatively small. So if I'm looking at my table here, the first one has a sample size of 10, which is kind of small, but notice it says we know very little about our distribution. If it says that in there, that means it's unclear and we really don't know should we use the Z or the T. The next one, sample size is 14. It is normally distributed, but we do not know what the standard deviation is. If it's an unknown standard deviation, then that's when we use the T distribution. The next one has a sample size of 17. It is normally distributed, and we do know the standard deviation. Anytime we do know the standard deviation, we are going to use the Z table, the Z score. The next one says it has a sample size of 75. It's from a non-normally distributed population, And so if it's from the non-normally one, that's the one where we could either use the Z or the T. And then the last one, sample size is 90. It's from a non-normally distributed population, but we do know the standard deviation. Anytime we know the standard deviation, we're going to use the Z. So our table looks something like that. Okay? So if you do know the standard deviation, and it says that right in the problem, going to use the Z. We'll get to word problems next week, and so that's why they want you to be able to pick out which table you're going to use. All right, so here again, on number 1, it says our sample size is 17. It's from a normally distributed population with a known standard deviation. If it says that, which one are we going to use?
Z.
The Z. Number 2, we have a sample size of 18. It's from a population distribution which we know very little. If it says that, we're going to pick
Unclear.
unclear. We don't know enough to figure out which one we should use. It's unclear. The next one, our sample size is 90. It's from a non-normally distributed population, but we don't know if we have the standard deviation or not, so we are going to say that we could use Z or T, since it doesn't say anything about our standard deviation. Next one, sample size is 14, normally distributed population. The standard deviation is unknown. We would use the T, since our standard deviation is not known. And the last one, our sample size is 100. We have a non-normally distributed population, but we do know the standard deviation.
Z.
So we use the Z, exactly. All right, number 12, same thing here. We have a sample size of 100. It is from a non-normally distributed population with a known standard deviation of 77. We would use
Z.
the Z. Number 2, the sample has a size of 20. It's from a normally distributed population with an unknown standard deviation. T. Next one, we have a sample size of 80. It's from a non-normally distributed population, and that's all we know. Z or T. Next one, our sample size is 18. It's from a population which we know very little. Unclear. And the last one, our sample size is 13. It's from a normally distributed population with a known standard deviation of 77.
Z.
Z. We know the standard deviation. All right. So 13, 14, and 15, we are going to find the confidence interval for the population mean. In other words, what two values can we be between to be in whatever percent they want us to do? Our formula that we are going to use is this. X bar, that's your sample mean. The sample mean plus or minus Z sub, they'll call it alpha divided by 2. The alpha is going to be the percent confidence that you're going to have. If I have a 95% confidence, again, I have 2 little sections on the end, and so I have to take that and divide it by 2. Alpha divided by 2 times the standard deviation, I can never draw that very well, mu, divided by the square root of n. And on the Alex calculator, they're nice. They actually do give you a plus or minus option instead of having to do 2 separate problems. So, the union for a particular industry has determined the standard deviation of its daily wages of its workers is $16. My standard deviation is that weird symbol there, and it's 16. A random sample of 50 workers, that would be my N value. How many people I surveyed? Has a mean daily wage of $118. So my X bar is my 118. Find the 95% confidence interval for the true mean daily wage of all union workers. So the alpha value is that 95%, which of course we use 0.95 for 95%. I'm going to mess with that in a little bit. So, well, maybe I'll just do it right away. Now that part of my table is the part in the middle. If you remember before where we were finding the two ends, so this is where we do that part where we're dividing by 2, but first of all we're going to do 1 minus that 0.95. Which gives me 0.05. 0.05 would be both of the two sections, but we only want one of the sections, so we're going to divide it by 2. And so we're going to use 0.025, and that's going to go in here for this value here. 0. Yep, let me erase that so I can write it so you can read it. 0.025. So the 95% is the part in the middle, but we want to find the section. We're just going to find the section on the end to the right is actually where we're going to find it. And so that's the number we're going to put in there. The X bar we knew was 118. So we're going to have 118 plus or minus Z sub 0.025 times standard deviation is 16 over the square root of n, which is 50. Oh, somebody lost something. I wonder who it's. Oh, it's yours? You might want those by the end of the class period anyway. All right. Now we're going to put that into the LX calculator. Okay, so 118 first, and then the plus or minus, which is right there, and then we're going to do the Z sub, which is this one, and we're going to use the 0.025 in the box, and then click up a little bit to the side of that because we don't want to be in the subscript anymore, or hit your space bar, that's the easiest way to do it. And then, whoops, hit your space bar. Nope, it's not going up. Why is that not going up? See if you can click. There we go. Then we're going to put our parentheses. In our parentheses, we're going to have 16 divided by the square root of 50. Click behind that. Whoops, close your parenthesis. And hit equals. All right. You have to scroll back and forth to see your two answers because the first one says slide your bar over. So your first answer to 1 decimal place is 113.6, and the second answer is
122.4.
122.4. Did you get those numbers? Got that all typed in right? All righty. So that tells me as long as I'm between 113.6 and 122.4, that 95% of my people will fall between those two numbers. All right. So next two, we're going to do the same formula on both of those. So again, X bar is my mean, plus or minus the Z sub, and they write it as alpha divided by 2, but we have to do a little work on that, times the standard deviation over the square root of n. So, the lifetime of a certain brand of electric bulb is known to have a standard deviation of 53 hours. Standard deviation we know is 53. Suppose that a random sample of 90 bulbs, so we know the N is going to equal 90, has a mean lifetime value of 475 hours. X bar is going to be 475. This time we're going to do a 99% confidence interval. So, that's going to be a lot of our table. 99% is going to be in the middle. We have to find the end, and so we said we were going to take 1 minus the 0.99 first, which gives you 0.01. Because there's 2 sections, we're going to divide it by 2, and so we would get 0.005. So 0.005 here, 0.005 is also over there, but that's the number we're going to use then in our Z sub. 0.005 is what we're going to put in there for that value. All right. So our formula, X bar, 475, plus or minus Z sub 0.005 times standard deviation is 53 over the square root of N, which is 90. For 60.6 and what was that?
460.610.
Oh, we're going just to 1 decimal place, so we're just going to use 460.6. And our second value is 489.4. So from 460.6 to 489.4, 99% of our people would fall in that range. Notice that your mean value is somewhere between those. So if you're looking at your answer and this number isn't between the upper and the lower, you know you typed something in wrong, right? Your mean is your average, so your average should be between your upper and your lower limits.
Can you tell me why this isn't working?
Let me see here. Oh, because see how this is dropped down? We didn't get it up. Remember we were having trouble with that? Just backspace it. Keep going. Keep going. There you go. Now we have to click up here higher. There you go. So the parenthesis isn't in that subscript. Now try her. So we have 53 on the top divided by the square root of 90. Click right behind there and close your parentheses and hit E. There we got our numbers. Okay? All right, 15 is the last one on this page. The mean diastolic blood pressure for a random sample of 80 people was 88 millimeters of mercury. The standard deviation of the individual blood pressure readings is known to be 12 millimeters of mercury for a 90% confidence interval. For the true mean, we want to find our lower and our upper limits. So, our X bar, our mean value is going to be the 80 is which value? the n value. What's the x bar value? The x bar value is the mean, which it says is 88, right? Says the mean diastolic blood pressure for a random sample of 80 was 88. So 88 plus or minus Z sub. We have to figure out what number should go in there for our subscript if we're going to do a 90% confidence interval. So 90% is in the middle.
1 minus 0.90.
So we're going to do 1 minus 0.9, which is 0.1, and then we're going to divide it by 2 because we have 2 sections, which gives us
0.05.
0.05. So this is 0.05. This also has an area of 0.05. The whole thing adds up to 100%. So we're going to use 0.05 there. Times our standard deviation is 12 over the square root of n, which is 80. And there's our numbers we're going to plug into the calculator.
And
85.8
90.2.
and 90 point what?
0.2.
90.2. So 90% lie between the 85.8 and the 90.2. Again, you can see the mean value 88 would be between those two numbers. So it gives you a good idea that, yeah, you punched that in correctly. The mean should be in the middle of my upper and lower somewhere. Okay.